Welcome, everyone! Imagine we're stepping right onto the factory floor together today. For this explainer, I'm basically going to be your technical consultant, and we are going to diagnose and totally cure some of your absolute biggest manufacturing headaches. If you've ever stood next to a production line literally pulling your hair out over mysterious quality drops, well, you're in exactly the right place.
So have you ever wondered how a plastic product can sit outside in the blazing sun for, say, 6 months and stay perfectly white, while another one just turns super brittle and cracks in a matter of weeks? Or hey, why some plastic bags stubbornly stick together like they're glued, while a premium bottle cap twists open with absolutely zero friction? These are kind of the most common symptoms I see on the floor every single day. And the ultimate cure to all of them is this highly specialized toolkit called Additive Masterbatch. Let's dive right into this.
Okay, before we start troubleshooting, we really need to define our primary tool. A lot of people hear the word Masterbatch and immediately just think of color. But Additive Masterbatch, which is often called Performance Masterbatch, is a completely different beast. Its job is not to give the plastic a pretty color. Its job is to dramatically improve the plastic's physical properties. We're talking about engineering superior performance, right? Things like UV resistance, slip, and overall processability. We are basically engineering survival. So, here's our consultant's inspection report for today. We'll be hitting 1. Masterbatch anatomy, 2. Environmental and heat damage, 3. Friction versus blocking, 4. Extrusion machine problems, and 5. R&D strategies. Let's kick things off with Section 1, Masterbatch anatomy, the 3-part formula. Every additive masterbatch relies on a pretty brilliant 3-part formula. Step 1 is the active additive. This is the heavy lifter, right? It does the actual work, whether that's a UV stabilizer, a slip additive, or an antioxidant. But it can't just go into the machine by itself. That brings us to Step 2, the carrier resin. This has to be perfectly matched to your application, whether you're using PP or PE. Finally, Step 3 is the processing aid. Think of this as the delivery mechanism. It improves dispersion and makes sure the whole mixture flows smoothly. The active ingredient absolutely needs the carrier and processing aid to do its job. Moving right along to Section 2, curing environmental and heat damage. So we can actually contrast the two most aggressive enemies of plastic here. Up top, we have UV radiation. When a product is outdoors, the UV rays in sunlight quite literally bombard and break the polymer chains. The heartbreaking symptoms? You'll see color fading, really aggressive cracking, and just a catastrophic loss of strength. On the bottom, we have a totally different enemy, thermal oxidation. This happens indoors, right inside your machinery. During processing, polymers go through incredibly high temps. Combine that intense heat with oxygen, and your polymer is degrading before it's even a finished product. The symptoms here are yellowing and totally unpredictable changes in the melt flow. So what's our prescription? Well, for outdoor sunlight damage, we use UV stabilizers. These are super clever. They actually absorb or neutralize the UV energy before it can break the chains. And for that intense processing heat, we prescribe antioxidants, which specifically protect the polymer from thermal oxidation while it's trapped inside that hot machinery. Now let me be incredibly clear here. If you're making agriculture films, water tanks, outdoor furniture, automotive exterior parts, or outdoor cables, UV stabilizers are non-negotiable. Seriously, I've seen manufacturers try to rely on just color masterbatch to protect outdoor stuff, and it is a guaranteed recipe for failure. Color alone just won't protect the structural integrity of your polymer. And here's a consultant's inside tip for those high-temperature processing woes. If you want the absolute most robust heat protection, the industry standard isn't just picking one antioxidant, it's actually combining both primary and secondary antioxidants. They work together to catch different stages of oxidation, giving you a complete shield for your polymer. All right, on to Section 3, solving friction and blocking. Okay, we need to address a massive industry mistake right now. People constantly confuse slip and antiblock additives, but they cure two entirely different diseases. On the left, a slip additive lowers surface friction. Its only job is to make the film slippery so things like bag openings slide perfectly. On the right, Antiblock Masterbatch solves blocking, which is when two layers of plastic film practically weld themselves together in a roll. Antiblock fixes this by intentionally creating micro roughness on the surface to keep the layers separated. Totally different functions. So what raw materials do we actually use for these? Well, for slip, we usually rely on active ingredients like oleamide or arekamide, perfect for standard films and bags. But for antiblock, where we need that microscopic surface roughness, we prescribe minerals like silica or talc. You'll find these are absolutely mandatory in things like food packaging or stretch films where easy separation is mission critical. Here's a major operational reality you have to understand. Slip additives do not work instantly. They actually need time to migrate from the inside of the polymer to the surface. I literally can't tell you how many times I've seen an operator panic because the film isn't slippery right off the line, so they just dump in double the slip additive. And then, a few days later, the slip has fully migrated and the film is completely ruined because it's covered in this gross, greasy layer. You have to give the chemistry time to migrate. Next up, Section 4, Fixing Extrusion Machine Problems. Look, when an extrusion machine is stressed out, it literally screams at you through the product. You'll see symptoms like melt fracture or shark skin, where the surface of the plastic looks all rough and jagged. You might get aggressive dye buildup, which means you have to constantly stop the line for cleaning. Or your machine might be pulling dangerously high torque, just struggling to push the material out. These are highly specific defects that absolutely ruin your productivity. The ultimate stress reliever for an overworked machine? Processing Aid Masterbatch. Basically, think of it as a lubricant for the exact moment the polymer exits the die. It smooths out the extrusion, drops the operating pressure, cures that awful shark skin finish, and naturally bumps up your productivity. Honestly, it's a total game changer on the floor.
Finally, Section 5, Expert Consultant R&D Strategies.
Welcome to my Consultant's Hall of Shame. These are the worst offenders I see. Overusing expensive UV stabilizers for stuff that just sits indoors. Treating slip and anti-block as the exact same thing. Using a PE carrier resin in a PP application, which just ruins the dispersion. And the absolute biggest rookie mistake? Just increasing the dosage when a problem pops up. Look, more is not always better. Every single additive has an optimum dosage. If you exceed it, you're just going to create a whole new set of headaches. A real pro never just randomly picks an additive out of a catalog. Before designing anything, they ask these golden R&D questions. Is this living indoors or outdoors? Are we running film extrusion or injection molding? Is this for strictly regulated food contact or some heavy-duty industrial thing? And finally, what's the expected lifespan? The answers to these dictate literally every chemical choice you make. If you only remember one thing from our inspection today, let it be this. Performance is decided by the additive package, not just the polymer. You can buy the absolute highest grade raw plastic on Earth, but without the right stabilization, slip, and processing aids, it's gonna fail. The additives are the invisible engineers of your success. We've covered a ton of ground today, but we aren't done yet. In our next explainer, we're diving straight into filler masterbatch technology. We'll be looking at calcium carbonate, talc, how they impact mechanical properties, and some serious real-world cost reduction strategies. You definitely won't want to miss it. So, I want to leave you with one final thought before I step off your factory floor. Take a hard look at your own production lines and ask yourself, are you just pushing raw polymer through a machine and hoping for the best? Or are you using performance master batches to strategically engineer its survival? How you answer that is the difference between constant troubleshooting and actual manufacturing excellence. Thanks so much for joining me for this explainer, and I'll catch you.
So friends, today we explore how Additive Masterbatch including UV, stabilizer, antioxidant, sleep agent, anti-block agent, and processing aids play a critical role in improving the performance, processability, and survive life of plastic product. If you are a polymer engineering student, CPET student, quality engineer, production engineer, R&D professional, or working in the masterbatch industry, this knowledge is initial in the plastic industry. Understanding the selection, dose, compatibility, and application of additive is what make the real difference. If you found this video valuable, please like, share, and subscribe to the channel CPET Polymer Tech channel. Don't forget press the notification bell so you never miss our upcoming video on masterbatch technology, polymer testing, compounding, processing, troubleshooting, and R&D. Also let me know in the comment which topic you would like to learn next, what challenge you are facing in your work or study. Your question may become the topic of our next video. Thank you for watching. I am Sumit Kumar and I will see you in the next video with another practical and industry focused lesson. Until the keep learning, keep innovating, and keep growing.